Assalamualaikum warahmatullahi wabarakatuh and hello everyone. My name is Izzatul Husna binti Ishak with metric number of CN 190 and 196. I am a third year student from BNA. In this video, I will present on my final year project regarding the characterization of nanocellulose filter paper from NEOLAMARCKIA, CADAMBA through high performance filtration in wastewater treatment. Okay, the subtopic of this video will be as below. First is introduction and problem statement of the research. Second is the objective of the research, and then is scope of this research. For the next section, I will briefly explain on the material used in this research and followed by the methodology applied in this research. So before we look into the problem statement, we already know that the water pollution has been described as a global problem that leads to a shortage of fresh water, which causes the demand for developing the eco-friendly wastewater treatment technology. Water pollutant can be categorized as a point source and non-point sources. According to EPA, which is Environmental Protection Agency, the point source pollution refers to any single identifiable sources such as factories and sewage treatment plants. As we look into today's trend, textile industries has been one of the fastest growth as the demand on the daily products such as textile yarn, fiber and fabric increase. However, with the increment of the production also leads to the expansion of the dyes that function to give colors on the products. The untreated dye that is being dumped right away towards water resources such as rivers and lakes will lead to the water pollution. Okay, according to Checker et al. 2013, it has been estimated that the losses of colorants to the environmental exceeds 10 to 50% during the dyeing process. Due to this problem, textile wastewater tends to have a high pH and high concentration of suspended solids and high BOD and COD. And then the uncontrolled discharge of the dye effluents will lead to the environmental impacts, such as it will affecting the human health and also disrupt the ecosystem. Okay, here are included some of the water pollution caused by the discharge of the dye effluent. So you can see that in the picture, the river turns into red color as the dye effluent are being discharged into the water. Okay, next, so considering the issues relating to the water pollution, this study is conducted in order to remove the synthetic dyes from textile and industry wastewater solution. Plus, the objectives of this study is also to elucidate the effect of the CNF filter paper falling, and also next is to check the reusability of filter paper during the filtration process. Okay, so these objectives can be achieved by getting the sample of the textile wastewater from textile industry, and then the dye removal testing will be conducted in the environmental laboratory. The testing will involving the usage of the filter paper made from CNFs, which is cellulose nanofibers obtained from the wood chips of NEOLAMARCKIA CADAMBA, or also known as kelampayan, that can be found in frame. Recently, the application of cellulose in dye effluents removal has become a famous method among the researchers. So cellulose is actually referred to the agricultural residue-based adsorbent used for the removal of heavy metal impurities such as woods and cottons. Okay, according to Hokkanen et al. In 2016, cellulose has a large number of hydroxyl groups on the cellulose surface. On the other side, nanocellulose is a formation of nano-sized cellulose, which is a lot smaller than the cellulose sizes, with a dimension of 100 nanometers or even smaller. And also it has a very high crystallinity and mechanical strength high water holding capacity, and also it is biocompatibility and biodegradability. Okay, so nanocellulose consists of three types here, which are cellulose nanocrystalline (CNC), cellulose nanofibers (CNFs), and also bacterial cellulose nanofiber (BCNF). In this research conducted, the nanocellulose chosen is CNFs, which gained from the NEOLAMARCKIA CADAMBA that is already available in frame. The reason of choosing these sources is that it can easily get, as it is fast growing tropical timber species, and it is also one of the renewable material sources which did not cause harm towards environment. Not only that, the CNF materials also have a high mechanical strength, which is good for removing the contaminant of the water in the water. In 2015, research has been done by Chan et al. Involving CNF, which was obtained from KNAF coal using an acidified chloride bleaching method. And then a study conducted by Modner et al. In 2019 shows the filtration capacity of the filter paper up to 60 milligram. Okay, in this study, the CNF used is based on the Pinus cassia species. And then for the next study, which is the latest study, has been conducted by Latifa et al. In 2020 by extracting CNFs from the NEOLAMARCKIA CADAMBA. So the research gap in this study is that the sources of the CNFs is from the Kelempayan tree, and also the dosage of the cellulose is also differ, which is 5, 10, 15, 20, 25 and 30 gram. And then we move to the next section, which is methodology. So here is the design of flow of the research. The first step is getting the wastewater sample and also CNF's filter paper. And then the next step is by doing the characterization of the CNF's filter paper by using FTIR and zeta potential method. And then the testing on the dye effluent will be conducted, and obtaining the characterization of the textile dye effluent, such as pH, total suspended solid, total dissolved solids, chemical oxygen demand and conductivity. And then the testing will be conducted by selecting various cellulose dosage, initial dye concentration and also system pressure. After the result gained from the experiment, and then we can do the interpreting and analyzing of the data. Okay, so next, just now I mentioned about the FTIR and zeta potential as characterization method of the CNF's adsorbent. So FTIR is actually function to investigate the nature of the sample surface and functional groups. Meanwhile, zeta potential is done in order to verify the surface charge characteristics of CNF's filter paper. Okay, next, the testing of the dye removal will be conducted by using cross-flow filtration. Cross-flow filtration is when the flow is applied tangentially across the membrane surface, and then as feed flows across the membrane surface, filtrate passes through while concentrate accumulates at the opposite end of the membrane. The tangential flow of the membrane creates a shearing effect on the surface of the membrane, which in turn reduce the falling in the water. After undergo the cross-flow filtration, there are three analyses that will be conducted by wastewater sample. First is normalized flux analysis, which is used to evaluate the CNF's filter paper falling behavior during the reaction in the cross-flow filtration system. Then next is the water sample will be tested for pH, BOD, COD and also turbidity analysis. The analysis will conducted according to the guideline provided in APHA in 2012. And also last method is decoloration efficiency analysis, which is aimed to analyze the percentage of the color removal in the wastewater. Okay, next is the selection of independent variable and range, such as effects of cellulose dosage, initial dye concentration, and system pressure. Okay, cellulose dosage has different range from what I've told before, which is from 5 to 30 gram per meter cube. And then for the initial dye concentration, different sample of textile wastewater will be taken. And then lastly, the system pressure applied also have a differ range, which is ranging from 1 until 5 bar in order for us to produce respective thickness. I think that's all from me. Thank you so much for watching, and Assalamualaikum.